Welcome back to my workshop. Now today I'm attempting to do a bit more wood turning. As you can see, I've been doing it for about 2 seconds. Floor's covered in rubbish. Okay, but I've got a problem with my lathe. It's been a problem for quite a while. It doesn't start very well. Let me show you exactly what's happening. So the lathe's been doing that for quite a while and I've never got around to fixing it. So what I'm going to do now is attempt to fix it. But what I want to do is explain what's wrong with it. Now I suspect it's this part. Let me show you. This part here, which is the start capacitor. Now this is a single phase motor and the start capacitor, I believe, is not working very well. Now the start capacitor is one of these little fellas. But what does it do? Let's go over to Professor Workshop and he will explain exactly what's wrong. Okay, what I'm going to try and do now is as quickly as possible, I'm going to explain what I think is the problem and basically how I'm going to fix it. So let's imagine this is our motor. Okay, in your motor you have poles. There's a pole and there's a pole. Into the motor you put electricity. In this case it's alternating current, so basically the current goes backwards and forwards. Okay, then what happens is there's a coil around this pole and then another one around this pole. Okay, now let's imagine the middle of the motor is a magnet like this one. Okay, so when the electricity goes in, so we're on this part of the circuit, okay, so with positive electricity, it goes through here, round the coil, a coil round a core will create a magnetic field, okay? That will cause this to be, say, a north pole and this one to be a south pole. Now here we've got north and here we've got a north. They don't like each other, they try and repel each other, okay? And this north is attracted to the south pole. So it turns round. Okay, it's moved. Then when it gets into this part of the alternating current, the current goes in the opposite direction. It goes this way. So this becomes a north and this becomes the south. Oh, and that's what happens. Okay, then the motor turns again. So this goes up and down and this goes round and round. That's simple. Right, now what's happening here? When you start the motor, what happens is this becomes, let's say, a north and this becomes a south. Okay, and it generates a magnetic field across here, across these poles. Okay, now what happens is this magnet doesn't know whether to go that way or whether to go that way. Okay, so it sits there and goes right. So what we do is we add a capacitor. Right, so we've energized the coils. This wants to spin round, but it doesn't know which way to go. So what we do is we introduce a second set of coils or poles, okay, 90 degrees away from the original ones. Then what we do is we add the capacitor into the circuit. This goes round, first of all, to this pole, round and round and round, the same as this one, okay? Then it goes round to the other pole, okay? And then connects to the other side of the electricity. So what happens then is, here's our alternating current, it does that. What the capacitor does is it shifts the phase by 90 degrees. What does that mean? Well, this takes time to charge and discharge. So by the time this has gone, oh, positive, negative, okay, this has changed how long each part takes to charge and discharge. So it creates a phase shift, okay, which then does this. Okay, so you've got 2 lots of current passing through the same circuit. So when this gets to the stage where it wants to turn, but it doesn't know which way to go, by the time it does that, this second phase has charged this coil, okay, and this coil. So it's made this one a south, this one a north, which means that this is now attracting this way. Okay, then the circuit continues, or the cycle continues, and it basically tells the motor which way it's got to spin. Right, that is the very basics of how this works. So my idea now is change the capacitor on the motor and hope it works. Right, now we're all suitably confused. What I'm going to do now is show you quickly how I change this. First thing I've got to do, turn it off and unplug it, because we're playing with electricity and that hurts. Right, luckily for me, I've got a swivel headed lathe. So what I'm going to do is I'm going to quickly spin the head round so I can access the motor. Right, so the first thing you've got to do is remove this cover, which is just 2 screws. Okay, and that exposes the capacitor. This is all quite warm because I've been using it. Okay, let's get this cover off. Right, potentially this capacitor still has a charge in it. So whatever you do, this has to be discharged before you change it. So let's take this cover off. Okay, so there's 1,000,001 different videos on YouTube explaining how to discharge this. I won't go into that now, but I'm going to do that before I actually cut into the wires. Okay, so I put my voltmeter on there to check how much voltage was actually remaining in here. By the time I'd made myself up a little discharge lead, most of it had discharged anyway, but ideally you want a little discharge lead with a 20 kilo ohm resistor in it, and then once that's across the terminals, that will discharge through the resistor. Then you could see there was no current left in it, so we should now be good to cut. Okay, and then dispose of this properly. Right, that's that. Let's put a new one on it. Here's a new one. Okay, so there's lots of writing on here. Most of it is in something I can't understand. All this lot, what the hell's that all about? Okay, let's compare it to our original one. Okay, 400 to 500 volts ACT, 450 volts, 50 to 60 hertz, 50 to 60 hertz, 10 microfarad, 10 microfarad. Right, okay, this one should be good to go. Right, let's bare back these ends and then attach it. Right, ironically, I haven't got a set of wire strippers. This is ridiculous. So I've got a set of work zone wire strippers, which I've not even taken out of the box yet. Let's see if these are any good. Okay, can't remember how much they were, probably about £7. Little set like this. Okay, we get some crimping tools, some crimps. Now I'm not going to use these, I'm going to solder it because I'm like that, I prefer it soldered. Okay, but I'm going to use these wire strippers to strip the wire back. So let's have a look at these babies. Oh, they work quite well. Right, so I'm going to solder this to this one. Now it's not polarity conscious, so we should be all right. It doesn't matter which way around we get it. Now I'm going to use a little bit of heat shrink. Okay, you'll see what that's all about in a minute. So I put a sleeve on each one. Okay, then I've got to solder this to this. And I'm going to use a little gas soldering iron. Okay, let's go and find some solder. Right, so I've sparked up my gas soldering iron. Looks very hot. Okay, now we're going to solder this. Now I'm going to try and do it through the camera, which is not very good, but let's give it a go anyway. Okay, those two are soldered. Check, check. Yeah, it's still quite hot. Then you put the heat shrink over the top. And now I'm just going to use one of these little blow torches to apply a little bit of heat, just to shrink it down. If I can turn it on with one hand. Now you'll notice I'm using this and there's loads of sawdust everywhere, so we've got to be careful. Okay, just apply a little bit of gentle heat and it shrinks the heat shrink, because that's what heat shrink does. Okay, turn this fan off. Right, that soldered to that, should be good to go. Right, so before we box all this lot up and put it back in its case, what I'm going to do is I'm going to try it. So we can plug it back in now. If we can find the plug. All right, we have the plug. Okay, on. Check to make sure there's nothing untoward happening here. No noises, haven't let any smoke out. Okay, so before when we turned it on, this really struggled to get going. So now the speed is still set on the same. 3, 2, 1. Stop. Okay, that looks like a success. Let me box this back up. Okay, so that's about it. Changing my start capacitor has fixed the problem, so now I can carry on with what I was doing. Right, remember, don't try and do any electrical stuff unless you're quite confident that you know what you're doing, because it can hurt. It's not the best thing to get hurt by. Okay, these things can carry a nasty charge, and if you discharge it through your body, you're going to know about it. All right, okay. Sorry about the science bit in the middle, if that was a bit boring for anyone, but that's what it's all about. Right, thank you very much for watching, and I'll see you in the next video. Bye. Right, that was a minute. No chance. Unplug it, because I don't want to get electrocuted. Electrocuted? Let's do that bit again because that's a bit confusing.